Hi from Tokyo, Japan, and welcome to Jeremy's IT Lab. In this video, we're covering route summarization, also called route aggregation, the process of configuring one larger prefix that represents multiple smaller networks. The payoff is smaller routing tables and simpler routing updates between routers. I'll show you how summarization works, when to use it, and how to configure static summary routes. Let's get started. We won't review how to subnet in this video, but here's a quick refresher on what subnetting is. Subnetting is the process of dividing a larger address block into smaller subnets. Each time you add 1 to the prefix length, you double the number of subnets and halve the number of addresses per subnet. So if you start with a /24 address block, you have 256 total addresses. By extending the prefix length to /25, you can divide that /24 block into 2 subnets, each with 128 addresses. You can further divide each of those /25s into 2 /26 subnets, giving 4 subnets with 64 addresses each. Likewise, you can divide each of those /26 subnets into 2 /27s, giving 8 subnets, each with 32 addresses. And you can divide those /27s into 16 /28 subnets, each with 16 addresses. You can continue the process up to /32, depending on the size of subnet you need. Subnetting combined with VLSM allows you to flexibly create subnets of appropriate sizes as needed, and this is a cornerstone of modern network design. So that's subnetting. Now let's look at the opposite process. Summarization, or aggregation, is the process of combining multiple smaller subnets into a larger prefix that contains all of the summarized subnets. It's basically the opposite of subnetting. In fact, it's also called supernetting. So let's say we have the following subnets: a /25 subnet with 128 total addresses, a /26 subnet with 64 addresses, a /27 subnet with 32 addresses, and 2 /28 subnets, each with 16 addresses. These subnets can be summarized into a single /24 prefix. This one /24 contains those 5 smaller subnets. It's a summary of those subnets. Now you might be wondering about why we would want to do this. It's all about routing. The purpose is to replace many more specific prefixes in the routing table with one less specific prefix, so the routers have fewer routes to store and exchange. It's most commonly done in dynamic routing to reduce routing table size and limit routing updates. But in this video, we'll focus on summarizing static routes and cover protocol-specific configuration later in the course, when we look at OSPF, EIGRP, and BGP. To see the benefits of route summarization, let's first configure some routes without it. Here we have R1 connected to R2, and behind R2 there are 5 subnets: 192.168.1.0/25, .128/26, .192/27, .224/28, and .240/28. Let's configure static routes on R1 so that it can forward packets to those subnets. First to 1.0/25, then to 128/26, then the route to 192/27, the route to 224/28, and finally the route to 240/28. So we've configured 5 routes, 1 to each subnet. Here are those routes in R1's routing table. This works, but it's much easier if we summarize these routes into a single route, 192.168.1.0/24. After removing those 5 specific routes, I configured just this one /24 route, and here it is in R1's routing table. This one route fulfills the same purpose as those 5 more specific routes. If R1 receives a packet destined for any address in the 1.0/24 range, it just needs to forward the packet to R2, and R2 will take care of the rest. For example, if R1 gets a packet for 1.10, it will forward it to R2, and R2 will forward the packet to the appropriate subnet. Likewise, if R1 gets a packet to 1.252, it will forward the packet to R2, and R2 will forward that packet to the appropriate subnet. So there's no need for R1 to know about each specific subnet connected to R2. This single summary route can be used to forward packets to any of the subnets. You might not realize it, but you've configured summary routes before. A default route to the internet is an example of a summary route. Instead of configuring routes to every possible destination that exists on the internet, you configure a summary route that includes all possible destinations. In other words, a route to o.o.o.o/0. So you get this one static route instead of individual routes to the roughly 1 million IPv4 prefixes that exist on the internet today. Now let's see how to summarize routes. We'll start with the same example as before, summarizing these 5 subnets. There are a couple of methods to do it, but I'll show you the method I prefer because it's the most fail-safe method. First, identify the lowest network address and the highest broadcast address among the subnets you want to summarize. Here are the ranges for these subnets. The lowest address is 192.168.1.0, the network address of the lowest subnet. And the highest address is 192.168.1.255, the broadcast address of the highest subnet. So if our summary includes these two addresses, we know that it covers all of the addresses between them too, since they're the lowest and highest addresses in our desired range. Next, write those two IPs in binary. Here they are. Finding the summary from here is simple. Just identify the common bits between the two addresses from the left. That's the first 24 bits in this case. The summary's network address is the common bits, with the remaining bits set to 0. And the summary's prefix length is the number of common bits. So that gives us 192.168.1.0 with a /24 prefix length. This covers the range from 192.168.1.0 to 255, all of the addresses we need. Now let me point out that these subnets could be summarized in several ways. For example, 192.168.0.0/23, because the first 23 bits of the lowest and highest addresses are common. Or O.0/22, since the first 22 bits are common. And you could keep going all the way to 128.0.0.0/1, using only the first common bit, or O.0.0.0/0, a default route. Technically, those are all valid summaries, but they include lots of addresses that are outside of the desired range. When summarizing routes, you usually want the most specific summary, the summary that covers all of the desired addresses with the longest prefix length, so you don't include a bunch of addresses that you don't actually want to summarize. For example, the 192.168.0.0/23 summary includes all of 1.0/24, but it also includes O.0/24, which is outside of the range we're trying to summarize. Now let's practice. This time we have 6 subnets: 172.16.0.0/24, 1.0/24, 2.0/24, 3.0/25, 3.128/26, and 3.192/26. Let's summarize them into a single prefix. I recommend pausing the video here and trying it yourself first. Just like subnetting, you need to practice to get good at this. Although if you're already comfortable with subnetting, this should be much easier than learning that for the first time. Okay, let's go through it. First, identify the lowest and highest addresses in the range. Here they are, from 172.16.0.0 to 172.16.3.255. You don't actually have to write out the range of every single subnet like I did here. The lowest address is clearly the network address of the first subnet, and the highest address is the broadcast address of the last subnet, so you can just write out those two to save time. Okay, next, write out the IPs in binary. Here they are. Now let's find the summary by identifying the common bits between the two addresses from the left. The summary's network address is the common bits, with the rest set to 0, with a /22 prefix length this time. So here's the answer. We can summarize these subnets as 172.16.0.0/22. So instead of configuring 6 routes, we'd be able to configure just this one. Up to now, these have been what I call perfect summaries. The summary covers exactly the address range we want. For example, we wanted to summarize 172.16.0.0 through 3.255, and 172.16.0.0/22 matches that range perfectly. Same idea in the earlier 192.168.1.0/24 example. But in real networks, it doesn't always line up so cleanly. So next, let's look at a few imperfect cases. This time we have 4 subnets. Let's summarize them. Once again, I recommend trying this yourself for practice, but let's go through it. Here's the range of each subnet. The lowest IP is 10.1.0.0, and the highest IP is 10.1.1.223. Let's write those two addresses in binary like this, and then find the common bits, which are the first 23. So that means that the summary is 10.1.0.0/23. This works, but it isn't a perfect summary like the previous 2 examples. Instead, this is what I call an imperfect summary. And why is that? Well, this is the address range of the summary. Notice anything off? Look at the highest address in the 4 subnets and the last address of the summary. The summary extends beyond the range we actually needed, so it includes extra addresses we didn't intend to summarize. That's an imperfect summary. Let's visualize it. We have these 4 subnets and summarize them into 10.1.0.0/23 with a total of 512 addresses. But the number of addresses on the left doesn't add up to 512. 256 plus 128 plus 64 plus 32 is 480. So there are 32 additional addresses, the 10.1.1.224/27 range, that are included in the summary, but not in the 4 subnets we were originally trying to summarize. Think back to subnetting. When subnetting, you often can't make subnets of exactly the right size. For example, if you need 100 host addresses per subnet, the smallest subnet you can use is /25, which gives 126 host addresses. That's just how power of 2 math works. If you used /26, you get 62 host addresses, which is too few. Similarly, when summarizing routes, it's common for the summary to contain extra addresses that you didn't intend to summarize. In other words, an imperfect summary. I won't go deep into network design here, but imperfect summaries aren't automatically wrong. You just need a plan for the extra address space. If that extra range is used somewhere else, make sure routers learn more specific routes for it, so traffic to those addresses doesn't end up getting forwarded via the summary route. It's totally fine to have a more specific route overlap with the summary route, something like this. Packets that match the more specific route to 224/27 will be forwarded along that route, and others will be forwarded along the summary route. Let's continue with another example to practice. Once again, I recommend trying it first yourself, but let's walk through it together now. First, we need to find the lowest and highest addresses, the network address of the first subnet and the broadcast address of the last. Write the 2 IPs in binary, and then identify the common bits between the 2 addresses, the first 23 bits in this example. So now we have our summary route, 172.20.8.0/23. It covers from 172.20.8.0 to 9.255. As you might have noticed, the range of the summary doesn't match the range of the subnets we're trying to summarize. So once again, we have an imperfect summary. Again, this isn't necessarily a problem, but just be aware that the route contains addresses that aren't part of these 5 subnets we summarized. And let's do one final example, summarizing these 5 subnets. Pause the video if you want to do it yourself, but let's walk through it now. Here is the range of each subnet. 10.1.8.0 is the lowest address, and 13.255 is the highest. So write those 2 addresses in binary, and then identify the common bits. This time it's the first 21 bits. So our summary route this time is 10.1.8.0/21. It covers 10.1.8.0 through 15.255. But it's, once again, an imperfect summary. Let's take some time to examine the issue here. These are the 5 subnets we started with in this example. We summarized them into 10.1.8.0/21, but this prefix's range is much larger than the original subnets. There's a gap between the subnets where 10.1.10.0/23 fits, and some extra room at the end for this subnet. You could say that we've over-summarized. We've included lots of extra addresses that we didn't actually intend to summarize. In a situation like this, we might choose to use a different approach. Instead of one large imperfect summary, what if we summarize these 5 routes into 2 summaries? These 3 subnets fit perfectly into 10.1.8.0/23, and these fit into 10.1.12.0/23. The unused space isn't included in the summaries, so we have these two perfect summaries. When subnets are discontiguous, meaning there is empty address space between them, it might be best to summarize them using multiple routes. This has the upside of allowing for more precise summarization, but more summary routes are required, 2 routes instead of 1 in this example. Here's a rule of thumb. When the best single summary would include a big gap, split the subnets into the smallest number of summary routes that cover only what you need. That helps you avoid routing problems caused by summarizing extra address space that you didn't intend to include. So we've looked at the purpose of summarization and several examples of it, some perfect summaries and some imperfect ones. Now let's talk a bit about designing networks with summarization in mind. This isn't a network design course, so let's keep it brief. Good network design can reduce or eliminate the need to worry about imperfect summaries. With good planning beforehand, you can effectively summarize at key points in the network without including unwanted addresses in those summaries by accident. Here's a design goal to enable that. Assign addresses in contiguous blocks that map to the structure of the network. Let's see what I mean by that. In this network here, we have a clear hierarchy. R1 at the top, R2 and R3 below it, and sites A, B, C, and D at the bottom. Connected to site A, we have 172.16.0.0/24, 1.0/24, etc., up to 7.0/24. Site B has 8.0/24 through to 15.0/24. Site C has 16.0/24 through 23.0/24. And Site D has 24.0/24 through 31.0/24. These routers lower in the hierarchy have specific routes to each of their connected subnets, of course. But let's configure summaries on the routers that are higher in the hierarchy, R1, R2, and R3. Let's start with R2. It's connected to the Site A and Site B routers. Site A's subnets can be summarized as 172.16.0.0/21, and Site B's can be summarized as 8.0/21. These are both perfect summaries, including all of the subnets of sites A and B without extra addresses. I won't walk through the actual summarization process here, but if you want some extra practice, you could stop the video here and try to identify the proper summary routes on R3 and R1. Let's look at R3, which is connected to sites C and D. Site C's subnets can be summarized as 172.16.16.0/21, and Site D's as 24.0/21. Once again, these are perfect summaries. And now we come to R1. Via its connection to R2, it can access all of Site A's and Site B's subnets. And via R3, it can access all of Site C and D's subnets. Which summary routes would facilitate that? The answer is 172.16.0.0/20 via R2 and 16.0/20 via R3. With only 2 routes, R1 is able to forward packets toward all of the subnets below it, without needing 32 individual routes. And what if we have another router here, R4 connected to R1? How could we summarize the Site A, B, C, and D subnets using a single route here? We could configure a route to 172.16.0.0/19 with R1 as the next hop. Once again, this is a perfect summary with no extra addresses. A logical hierarchy like this allows for perfectly summarized routes at higher layers. It's often a good idea to leave room for growth inside each block of addresses, so new subnets can be added later without changing the summaries. In this diagram, each site is using its entire block, so the summaries are perfect. But for example, perhaps Site A only uses these 2 subnets at first, 172.16.0.0/24 and 1.0/24. If you plan on expanding it to include up to 7.0/24 in the future, it's perfectly fine to configure a summary on R2 that is larger than needed at first. That means you can add new subnets without having to modify the summary routes later. This is one case where imperfect summaries can be intentional, intentionally leaving room for future growth. It's similar to choosing subnet sizes. You often leave extra addresses so you can add more hosts later without redesigning the network. Sometimes it's better to have extra room now than to have to redesign later if you run out of space. Let's review the key points from this video. Summarization, also called aggregation, is the process of combining multiple smaller subnets into a larger prefix that contains all of the summarized subnets. It's also called supernetting, and is basically the opposite process of subnetting. The purpose is to replace many more specific routes in the routing table with one less specific prefix. So without summarization, we might have these 5 routes, but with summarization, those 5 routes can be replaced with a single /24 route, simplifying the routing table. Here's how to summarize routes. First, identify the lowest network address and the highest broadcast address among the subnets you want to summarize. Write those 2 IPs in binary, and identify the common bits between the addresses from the left. Now we can make the summary. The summary network uses the common bits with the remaining bits set to 0, and the prefix length equals the number of common bits. A perfect summary includes only the intended addresses in its prefix, only the subnets you intended to summarize. An imperfect summary includes extra addresses outside of the intended scope. But this is sometimes done intentionally, to leave room for additional subnets later. Another example of an imperfect summary is a default route. It includes all IP addresses, which works because more specific routes take precedence over the default route when forwarding packets. A well-designed hierarchical network facilitates proper summarization by assigning addresses in contiguous blocks that map to the structure of the network. If you just randomly assign subnets across the network, you're not going to be able to summarize effectively. For this video's quiz, let's summarize a similar network as in the last example we looked at, but with different subnets. On R2, find the best summary routes to Site A's and Site B's subnets. And on R3, find the best summary routes to Site C and D's subnets. On R1, find the best summaries to the subnets below R2 and R3, and on R4, find the best summary to the entire network. These should all be perfect summaries, containing all of the summarized subnets with no extra addresses. Pause the video to work it out yourself. Now let's check. On R2, how can we summarize the range from 10.40.0.0/25 all the way to 3.128/25? That's 8/25 subnets. The best summary is 10.40.0.0/22, which includes the entire range from 10.40.0.0, the network address of the first subnet, to 10.40.3.255, the broadcast address of the last. And for Site B, the summary is 10.40.4.0/22, which is again a perfect summary. How about on R3? We can summarize Site C subnets with a route to 10.40.8.0/22, and Site D subnets with a route to 10.40.12.0/22. Now let's summarize further on R1. For the subnets below R2, we can configure a summary to 10.40.0.0/21. This summary includes from 10.40.0.0 all the way to 10.40.7.255, the entire range. And the summary to R3 subnets is 10.40.8.0/21. Finally, what's a single summary route we can configure on R4 that includes all of the subnets in the 4 sites? It's 10.40.0.0/20, which includes all 32 of the /25 subnets. Okay, that's all for the quiz. And that's all for this video on route summarization. But this isn't the last time we'll look at summarization in this course. As I said earlier, summarization is often done with routing protocols like OSPF to simplify routing tables and limit advertisements between routers. So we'll get back to this topic when we cover specific routing protocols a bit later in the course. Thanks for watching, and I'll see you in the next video. Before we finish up, I want to say a quick thank you to the channel members whose names you see on screen. Your monthly support helps me keep making these videos and keep this content free for everyone on YouTube. I really appreciate it. Thank you for your support. If the video was helpful and you want to support me, click the join button under the video. And please subscribe and leave a like if you haven't. It really helps me to grow the channel and keep making these videos for you all. Thanks again.